Welcome back. Now let's talk about inverse hyperbolic functions and their derivatives. You can see from the graphs of sine hyperbolic and tan hyperbolic that the two functions are one-to-one on the entire number line. Let's go back to the graphs. That is sine hyperbolic. So notice it is one-to-one on the entire number line. Let's look at tan hyperbolic. There you go. That is also one-to-one on the entire number line. Cosine hyperbolic though is not one-to-one. So you can restrict cosine hyperbolic to the right hand side, that is 0 to infinity, then it is one-to-one. Okay, so that's what we are going to use. All right, so cosine hyperbolic is one-to-one on the restricted domain closed 0 to infinity, and the range of cosine hyperbolic is closed 1 to infinity. Now sine hyperbolic function, the inverse of sine hyperbolic function is from negative infinity to negative infinity to infinity. Okay, now we want to identify the inverse of sine hyperbolic. Step 1, set y equals sine hyperbolic, that is y is e raised to x minus e raised to negative x by 2. Now step 2, interchange x and y and then solve for y. So where I see y, I'll place x, where I see x, I'll place y. So x is e raised to y minus e raised to negative y whole over 2. Cross multiply, 2x is e raised to y minus e raised to negative y. 2x equals e raised to y minus, this is nothing but 1 over e raised to y. Common denominator, or you multiply throughout by e raised to y. So you get 2x e raised to y equals e raised to y times e raised to y. So that is e raised to 2y minus, multiplying this term by e raised to y is simply 1. Get them all together on one side. E raised to 2y minus e raised to 2x minus 2x e raised to y minus 1. All of this is 0. So notice you may view this as a quadratic equation, e raised to y, and this is e raised to y squared. So this is your unknown. E raised to y is your unknown. You are solving for it. Use quadratic formula to solve for e raised to y. Minus b plus minus b squared minus 4ac, notice the negative, the whole over 2a1, right? So all of that gets me 2x plus minus square root 4x squared plus 4 the whole over 2. So notice I can get 4 common here. When it comes out of the square root, it becomes 2. 2 and a 2 here divided by 2, they get cancelled. All I'm left with is x plus minus square root x squared plus 1. Notice x plus minus, x is always less than square root of x squared plus 1. Check with any x value. Okay. This happens on all of real number line. So since this is smaller, if I subtract, the result will be overall negative, but exponential e raised to y it always carries positive value. Therefore, we drop off the negative option. E raised to y is x plus square root x squared plus 1. In other words, y is natural log. You see, y is natural log of x plus square root x squared plus 1. In other words, you have found or identified the sine hyperbolic inverse function. Sine hyperbolic inverse function x is natural log x plus square root x squared plus 1, and this is defined for every x in the number line. Now let's find the derivative of sine hyperbolic inverse function. D by dx of natural log x plus square root x squared plus 1. Well, this is, you need to use chain rule. 1 over the argument times derivative of the argument. So that's a 1 plus. Here again, you require chain rule. So square root 1 over 2 square root times derivative of the argument inside, 2x. So notice that 2 cancels this 2. You need a common denominator here, root square root x squared plus 1. So multiplying by 1, you have numerator to be all of this. So notice the numerator here is essentially exactly the same as the denominator here. So that numerator cancels this numerator. Derivative is eventually 1 over square root x squared plus 1. So this is the derivative of sine hyperbolic inverse of x. Derivative of sine hyperbolic inverse of x is 1 over square root 1 plus x squared.